Hello everyone, myself Dr. NCH Ramgopal, working as Associate Professor in Mathematics in the Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. I welcome you all to today's session on CR equations in polar form. Today I am going to introduce the CR equations in polar form. What are CR equations? Cauchy-Riemann equations. So, we know the Cauchy-Riemann equations in Cartesian form. What is that? If we have f of z is in the form of u plus iv, where u and v are functions of x and y, then if dou u by dou x is equal to dou v by dou y and dou u by dou y equal to minus dou v by dou x, these are called the Cauchy-Riemann conditions or Cauchy-Riemann equations in Cartesian form. Now, today I am going to introduce the equations in polar form, and also we discuss some problems on CR equations in polar form. CR equations in polar form. Let us consider a function of complex variables f of z. You know f of z, where z equal to x plus iy in Cartesian form. Cartesian form. In polar form, this z will be z equal to r e power I theta. So, this is the complex variable in polar form, where here r square is x square plus y square and theta is tan inverse y by x. So, the function f of z now can be written in the form of u of r comma theta plus I into v of r comma theta. So, completely it is in polar form. Now, the CR conditions or equations in polar form are given by dou u by dou r is equal to and dou v by dou r equal to. So, dou u by dou r equal to 1 by r dou v by dou theta, and dou v by dou r is minus 1 by r dou u by dou theta. So, these two equations are the CR equations in polar form. So, to check whether the function is analytic or not, we need to check these CR conditions. If the function f of z is given in polar form, then we check these polar conditions. So, for that, first we need to find the partial derivatives of u and v with respect to r and theta. So, here in the first equation, dou u by dou r, the partial derivative of u with respect to r is equal to 1 by r times the partial derivative of v with respect to theta. Similarly, the partial derivative of v with respect to r is minus 1 by r times the partial derivative of u with respect to theta. So, these are called the CR equations in polar form. Now, let us solve some problems on this. If w equal to log z, find dw by dz, the derivative of w with respect to z, and also determine where w is not analytic. So, the means where the function ceases to be analytic, fails to be analytic, we need to find that point also. So, coming to the solution, given the function w equal to log z. Now, in polar form, what is z? So, we have z equal to r e power I theta. So, that implies this w becomes log of r e power I theta, which is in the form of log ab. So, log r plus log e power I theta. So, this is log r plus here log e base e. The result is, so log x log e power x base e, the result is x itself. And also we have, what is r square? X square plus y square. That implies r will be x square plus y square power 1 by 2. And theta is tan inverse y by x. So substituting these two, log r is x square plus y square power 1 by 2 plus I into tan inverse y by x. And again simplifying this, half log x square plus y square plus I into tan inverse y by x. So now this is in the form of u plus iv. So this w is in the form of u plus iv, where u is half log x square plus half log x square plus y square, and v is tan inverse y by x. Now let us check, since the equations are converted into Cartesian form, we can cross check the CR equations in Cartesian form itself. So let us find dou u by dou x, dou v by dou x, dou v by dou y and dou v by dou y, all the first order partial derivatives. Now dou u by dou x with respect to x, partially with respect to x. So half into the derivative of log x is 1 by x into the inner function derivative with respect to x. So we get the inner function is x square plus y square with respect to x, 2x. We treat y as constant, therefore the derivative is 0 here. So simply the answer is x by x square plus y square. Now dou u by dou y with respect to y. So again the same, half 1 by x square plus y square, the derivative of logarithmic function. Now inner function with respect to y, we get 2y. So which is y by x square plus y square. Similarly, we need to find dou v by dou y, dou v by dou x and dou v by dou y. So v with respect to x, the derivative of tan inverse 1 by 1 plus x square y by x whole square into the inner function derivative with respect to x. So dou by dou x of y by x, which is here x square comes to the numerator, x square plus y square with respect to x. So we treat y as constant and derivative of 1 by x is minus 1 by x square. So after simplifying this, we get minus y by x square plus y square, and dou v by dou y, that is 1 by 1 plus y square by x square, inner function derivative partially with respect to y. So x square by x square plus y square with respect to y. So we treat x as constant. So 1 by x is constant and derivative of y with respect to y is 1 itself. So the answer is x by x square plus y square. Now let us denote this by equation 1, 2, 3 and 4. Now clearly you can observe 1 and 4. Equation 1 and 4. Dou u by dou x is x by x square plus y square and dou v by dou y is x by x square plus y square. So therefore from 1 and 4, dou u by dou x is dou v by dou y, the first condition. And let us compare 2 and 3. Just the difference is the negative sign. So and from 2 and 3, dou u by dou y is minus dou v by dou x. Therefore, u and v satisfy CR equations. That implies the function w equal to log z is analytic everywhere except at the point 0, 0. It is analytic everywhere except at 0, 0. Because you can see in all these derivatives, we have x and y in the denominator. At the point x equal to 0, y equal to 0, the derivative doesn't exist because we get 0 in the denominator that tends to infinity, which cannot be defined. Hence, the derivatives exist only except at 0, 0. Therefore, Now, to find dw by dz, we have dou u by dou z plus I into, okay. If you want to find this, so it is required to find dw by dz. So, dou u by dou x plus I dou v by dou x. Now, what is dou u by dou x? X by x square plus y square. X by x square plus y square plus I into dou v by dou x minus y by x square plus y square. So, after simplifying this, we get x minus iy by x square plus y square. Now, we need to simplify this. X minus iy by, the denominator can be written as x plus iy into x minus iy. Because a plus b into a minus b, that gives a square minus b square, and minus I square becomes plus 1. Therefore, we get x square plus y square. And now we can cancel these two things. So, 1 by x plus iy. That implies dw by dz is 1 by z. So, that is very clear. If w is log z, what is its derivative? So, differentiating dw by dz becomes derivative of log z is 1 by z. So, both matches. And this derivative exists except at z equal to 0. If we substitute z equal to 0, that tends to infinity. So, for all values of z not equal to 0, the derivative exists. So, the function ceases to be analytic or fails to be analytic at z equal to 0. Similarly, let us solve one more problem. Find the analytic function f of z equal to u plus iv, where the real part u is given. So, the real part u is given u equal to a into 1 plus cos theta. So, that implies we can find dou u by dou theta, a constant, cos theta derivative is minus sin theta. So, minus a sin theta, and dou u by dou r, there is no r term, so the answer is 0. Now, from CR equations, we have, now what is the first CR equation? Dou u by dou r is 1 by r dou v by dou theta, and dou v by dou r is minus 1 by r dou u by dou theta. So, here we have dou u by dou theta. So, from equation 2, this is 1, this is 2. From equation 2, dou v by dou r is equal to minus 1 by r dou u by dou theta, that we have minus a sin theta. So, which is equal to a by r sin theta. This is dou v by dou r. Now, integrating on both sides with respect to r, we get v equal to a sin theta constant integral 1 by r dr. V equal to a sin theta 1 by r is log r plus some function of, we are differentiating with respect to r. So, phi of theta. We consider theta as constant. So, we got v. So, here we have the expression for dou v by dou r. By integrating that, we obtained v. Now, there is a constant term, phi of theta. So, you can consider this as constant, because here we have integrated with respect to r. So, we treat theta as constant. Now, to find this, let us differentiate this with respect to theta. So, again I rewrite this expression. We have v equal to a sin theta log r plus phi of theta. Now, differentiating partially with respect to theta, we get, so dou v by dou theta, dou v by dou theta is equal to, so a cos theta log r plus phi dash theta. But we have dou v by dou theta can be obtained in terms of dou u by dou r also. So from equation 1, dou u by dou r is 1 by r dou v by dou theta. So from this, dou v by dou theta is r dou u by dou r. And what is the value of dou u by dou r? 0. So this is equal to r into 0, 0. So that implies dou v by dou theta is equal to a cos theta log r plus phi dash theta is 0. From this, we can find the value of phi dash theta as minus a cos theta log r. Now by differentiating this, by integrating this, we can find phi of theta with respect to theta. So minus a log r integral